I'm going to present our work actually about on-device computational confidential AI. My name is Savas, and I'm working for Samsung Research UK as an engineering manager and AI tech lead. And also, we have some other contributors, obviously. Particularly, I want to thank to Boktaev, who is working for Samsung Research Korea. She is, she's one of the contributors actually for the submit, and she helped a lot actually to prepare the slides and our collaboration. Today's talk will be something like this. I will first introduce the problem, and then I'm going to present our motivation. Then I'm going to mention about the on-device computational confidential AI, and I will expand my talk to confidential agentic AI, which is hot topic actually. And at the end of my presentation, I will finalize with our key takeaways and final remarks actually. But in my talk, what I can say is that the main takeaway will be on-device AI is booming. Agentic AI is already here, as you noticed, and the one of the most important things is privacy will be never free. As I mentioned, AI is booming, and particularly for on-device application, you can see lots of actually on-device application running on your desktop or your mobile phone, but the privacy guarantees is not have the same pace. And I mean, if you are familiar confidential computing, and if you are from the privacy domain, we have sensitive data, we have AI models. Therefore, we need to consider the privacy in our application. Obviously, there are multiple ways to run AI models. One of them is cloud inference. I mean, you might already notice that lots of companies targeting for those cloud inference, but there are several problems, as you can imagine. One of them is the user data must be transferred to servers, and the model provider can inspect your data, and the communication channel between your device and cloud services are not encrypted most of the time. And another way of processing your data is on-device without CC. Obviously, if you don't have any protection, the attackers or, bad people can access your data and your model and try to reconstruct the private information or personal information you have on your device. The other one is software-based privacy, which is differential privacy they are calling. The way of attacking the privacy is they are adding some noise to your data. Therefore, the model cannot memorize your data when you train a new model. But the problem here is that the accuracy can drop 30%, up to 30%. Therefore, you need to adjust the privacy and utility trade-off for your specific use cases and data. And obviously, why we are here, TC is critical to protect your data and model without sacrificing any inference accuracy, unlike differential privacy. But obviously, there will be some cost. Industry recently moving to, all I can say, to on-device AI, agentic, and confidential AI, particularly. I'm not going to just talk about everything, but all I can say is the device can be optimized for on-device AI, and the recent trend moving to hybrid solution instead of only server-side solution, and also with the recent hardware improvement, particularly from NVIDIA. I'm not going to advertise their product, but the raw AI power for on-device is already here as well. And also some other models can fully run on device as well, like agentic model. And another thing that you might already notice that in EU, there's a regulation AI should basically provide some privacy and security protection for your data as well. On-device computational AI provides, obviously CC guarantees several things for AI. One of them is memory encryption, execution isolation, model integrity, and input privacy. But these are, these things are very critical and important for server-side applications. Or if you are Google or Microsoft or I don't know Apple, you can say that you provide these features. But from the Samsung perspective, actually, what we can also say that the computing device is in your pocket, actually. Therefore, you don't need to transfer your data to the server side, but all the computational resources for your AI models is in your device. Therefore, when you run on-device AI, particularly with CC feature, you can guarantee that you don't need to, basically your data doesn't need to leave your device. Data sovereignty is basically on your hands. You have full control of your own data and also reduce the attack surfaces. Obviously, we cannot say that even if you run everything on your device, it's not going to protect your data from the third-party attackers or bad people. Therefore, we are saying that we still need on-device CC to protect your data and models as well. The second, the important thing is, as you already know, CC encrypts your memory and isolates your execution, which is nice, but it will be never free. You need to pay some cost, actually. I divided this thing actually into 3 parts. What I can say is that basically there will be some technical obstacles that we need to solve. Actually, we need to solve. One of them is performance. If you are familiar with this thing, actually, accuracy will not drop, unlike differentiable privacy, but the inference time and model loading will introduce some overheads. Therefore, we need to address these issues. Sorry. And also, unlike server-side resources, our device, particularly on-device application, your resources is limited. Therefore, when you develop a solution, you need to consider these performance overheads or limitations. And also, another thing that I'm going to mention in this presentation as well, the communication is also critical, actually. Communication between normal environments and confidential environment is critical. Therefore, it needs to be addressed as well. And the one final thing is ecosystem. Currently, I'm not going to get into detail because I'm just AI engineer, actually, unlike security or privacy engineer. Therefore, in order to test everything and deploy everything, you need an ecosystem which provides some software compatibility and also adjust the privacy and accuracy trade-off, actually, and authentication. Obviously, in this work, if you, again, familiar with Samsung have a product called ISLET, which is a CC simulator for on-device application. Therefore, in all these works, we use this product to test our models. In this part, I'm going to talk about these overhead or limitation that we need to consider when we develop something for on-device CC application. Again, I divided this section into 4. One of them is obviously inference and execution overheads. In summary, we did lots of experiments with different type of model, and at the end, basically, when you run an AI model in PC environment, it's automatically introduce 10% overhead. And unfortunately, this is unavoidable and unavoidable. Therefore, you need to accept this thing if you want to run your model in CC environment. And the second overhead, which is also critical, is model loading time. When you initialize your model in CC, it takes longer than the normal environment. Therefore, there are lots of operations are happening. Therefore, you need to propose a new kind of design, I am going to say, to reduce this overhead. And which I'm going to mention about, we introduce a pre-mapping AI models, which instead of basically running AI models when we call them, what we are doing is this: we are just preloading in the beginning, and therefore we are reducing the overhead a lot, and we continue to use this model actually in the execution. And the third thing that I'm going to talk about in the following slides is the model type. Again, we are running our models on device, therefore our memory and computational resources are limited. Therefore, we need to find a way to put our models on device, which have the same task capability like large AI models, but we need to make them compact and we need to adapt them to smaller versions. And last thing that I'm going to talk about, message parsing, the communication between normal environments and confidential environments, and also between confidential environments, like the multiple confidential environments. And it's still obvious that there might be some other models or other solutions that you might also utilize. But basically, when you use protocol level solution, you can reduce this 10 times overheads a lot, actually. Let's start with the inference and execution step. Again, I said, and I will continue to say, that privacy will never be free. Therefore, there should be like some overheads that we need to consider. Obviously, there are two options currently. Obviously, in future, or maybe I don't know, you might know that. There might be two options to provide privacy for your model and your data. One option is, again, differentiable privacy. This is not familiar for confidential something AI domain, but differentiable privacy also provides some advantages to protect your data to stolen by other AI third-party companies or basically bad people. But the problem here, as I mentioned, accuracy, there will be an accuracy drop actually when you use differentiable privacy in your solution. The another solution is, since we are in CC submit, obviously CC is one of the solutions that we can utilize for on-device application. But this time, the overhead will be on the inference and execution part, which is approximately 10%. From the slides, from the figures, I hope, yeah, you can see that we did lots of experiments with different models, like from convolution models to transformer, LLM, pure LLM model, or VLM model, and also agentic models. And as you can see, the compared to normal environments, CC environment introduced approximately 10% overhead when you run your AI model in CC. There are some explanation for that one. I'm not going to get into detail. You guys might know better than me, but the main problem comes from the word switching stage. Basically, unlike the normal environment, there should be a periodic word switching. That's because CC doesn't have a separate CPU. Therefore, it's the confidential environments time to time should exist and check the register and do some operations and start the process again when an AI model runs. Therefore, this context switching is necessary but expensive, but also it's unavoidable. Therefore, obviously, in our at least work, we couldn't find a solution to reduce this 10% overhead, but its 10% is still acceptable compared to our overheads that I'm going to mention. The second thing that I wanted to mention about is the model loading time. Again, when you initialize your model, unlike the normal environments, it needs some extra overheads. Therefore, it's just because of the multiple repeating operations between host and LN, I'm going to say. And from our experiment, again, we did experiment with different models, from convolutional neural network to transformer-based architecture. And this overhead can go up to 90% actually, which is huge when you consider to run your model in CC actually. Therefore, what we propose is that instead of basically loading our model every time when we run our AI models, what we can do, we can pre-map our memory parts, and then we can load our model in the initialization step, during the initialization step, and we can continue to use that model actually when we are calling our AI model. Actually. Obviously, we adapted ourselves actually to CC environment because it might not be realistic, but it also provides some advantages. What I'm saying is that basically there are some constraints when we use this pre-mapping, like we should have fixed and single model. We need to know the parameter size in advance. Therefore, we are going to allocate some memory and we are going to load everything. But at the end, we can provide approximately 80%. We can reduce the overhead approximately by 80% at the end, which is, I mean, compared to the normal one, it's huge. And therefore, it's also make the AI on-device AI for CC in CC environment actually useful and practical. The other thing that I want to mention is the model size. Again, we are running on device, and therefore we have some limited memory capability and also some limited computational resources. Therefore, we cannot directly go and take the largest model and run on our device actually. But I need to also mention that when you use smaller models, obviously there are smaller version of the, for example, QM model, JAMA model, or any kind of public model. But the problem here is that when you use the small models for your on-device application, there will be a significant performance drop. This time, we are going to face with very critical problem, actually accuracy or the test performance. Therefore, what you can do is that when you reduce the number of parameters that you are running on device, you can start to adapt your smaller models for particular tests. How you can do it? Obviously, there are multiple solutions in the literature, but you can use like adapters like LoRa or other kind of model that basically distill the large model capability to the smaller ones through adapter. As you can see, when you do the fine-tuning for test-specific purposes of the smaller models, you can reach approximately same performance with the larger one, which is a nice thing actually, which makes that smaller model can be useful for on-device application as well. But obviously, what we face here is that in CC environments, when you have basically you need to convert everything to binary. Therefore, the current problem here is that when you have an adapters, you will have one fixed model and one fixed adapter. You need to convert everything to binary, basically, which is monolithic. Currently, the situation is like this, but actually, in the future, what we need to solve on this, particularly for CC or, I mean, on-device applications, we need to make this model more generic. What I'm saying is that we will have one model with multiple capabilities, which means multiple adapters, which this will provide us to basically protect the personal or task-related information in adapters, which is going to be treated as IP. But we can still continue to use base model, which can be public, and we don't need to protect that part actually in CC environment because it's already public. All the information that we need will be saved in the adapters. And the one final thing that I want to mention is that the communication between normal environment and confidential environment, and also confidential environment is another big problem. And when we did some very basic experiment here, and we find out that the connection actually, when you create the connection every single time when you send a message to the other confidential machine or normal environment, etc., you need to create the channel again, and it will introduce lots of overhead. Therefore, by basically applying a simple trick, for example, instead of using HTTP, using WebSocket, which means that you don't need to create the channel, communication channel every single time. You will have a single communication channel, and the message will go through that channel. Works very well, actually, in CC environment. Yeah, I'm going to be faster. And the last topic that I want to talk about is that agents are here, basically already here. Everyone is talking about that one. And particularly in this work, what we focus is that this is the basic flow for generic agentic system. There's a user, there's the orchestrator, which basically calls the tool based on the user command, and also there is another block which is, to be honest, recent and very critical for CC application, which is called memory. Obviously, this is not like DRAM. The memory concept here represents that, for example, you are interacting with your agent. You are talking about, for example, saying that just organize an event with my friend who joined my birthday party. Obviously, agentic system doesn't know who is your friends or who joined your birthday party. All those information must store in this part, in the memory part. Therefore, the memory part keeps or stores your personal data. Therefore, when you develop your solution for agentic system, you need to completely consider this kind of tools, that kind of, how can I say, modules, memory, language model orchestrator, and tools, actually. I'm going to be faster because I don't have too much time. Therefore, how you can do it, obviously, when you consider the memory parts, you can have a single confidential virtual machine, VM, or you can have multiple confidential virtual machines, actually. This is all up to your design. Obviously, each of them has their own pros and negative parts, which is basically for if you have a single confidential environment, then it's easy to implement and everything stored under one system. Therefore, the communication cost will be zero, but there will be no isolation between your orchestrator and your memory. Therefore, the bad people or attacker can easily steal your personal data by providing a right prompt, actually. Good. And for the two confidential environment, in the two confidential environment scenario, you are separating these two things. Therefore, you are isolating the language model from the memory part, your personal data. But this time you are introducing some extra overhead from the communication part. Therefore, what I'm going to talk here is that the memory significantly impact your performance when you develop or design an agentic system. In this work, we also try different memory types. Like if you are familiar with this domain, these three are the most familiar ones. Obviously, the everyday some new method is coming out, but these, based on your requirements, obviously, you need to decide which type of memory you need to use in your system. I'm not going to get into detail, but some of the memory types provide some high recall, but you need to interact with multiple times with language model, or for some other memory types, the online stage or online basically querying stage might be faster, but the offline stage will be longer and expensive. Therefore, for your design that I mentioned, like one confidential system or two confidential systems, you can choose this type of memory based on your requirements and configuration section. Last two slides. Takeaways. Obviously, thanks for joining this session. The takeaway that I can tell you is that on-device AI is also booming. I mean, instead of server-side, on-device AI is also coming actually. But we need to design our system in the beginning actually, if we want to add privacy in our system. Agentic agents are also here. They are powerful, yes, but without protection, they can be dangerous. Currently, everyone is speaking about this, and you will hear probably a lot in this summit as well. And the one final thing that I want to mention is that privacy will be never free. Therefore, there will be some cost. If you want to use it, you need to basically design your system and choose wisely based on your needs and requirements, actually. And one final thing that I want to talk, obviously, yeah, I'm not from this domain. I'm not from Submit, but CC community. But what we want to do, we want to share our experience and also our system as well. Therefore, what we are going to do, we develop our system, again, using one other Samsung product called ISLET. And we are going to release all the experiments, all the setups under this GitHub webpage, actually, GitHub website. And yeah, we are going to upload everything very soon. And if you want to obviously test them or add something on top of it, it will be very nice for the community.